Hello everyone, how's it going? This is going to be my screencast of the process that I use to create my project-based learning website about how we can make the Earth thrive. So using game design to drive climate awareness. This is a little sample of the site. So we're going to be addressing climate change through game design and simulation in a 1-month project-based learning program for 9th through 12th grade CTE students. The driving question is how can we use game design and development to bring awareness about climate change and current social issues to teachers, students, developers, and researchers from across the globe. So this project has been in the making for about a year now, for me and a couple other educators mostly, and a couple developers, but it's mostly game design educators at the college level. The project was made using Unreal Engine and Cesium, so it's essentially a game design engine using a plugin that is a scanned representation of the entire world. What we can do with that is up to our imagination. So our goal with this project was to create little experiences and scenarios that people can jump into and kind of have an impactful vision of what is causing climate change, what the effects might be in the future, and what we can do about it now. The goal of this project was to have students use what we kind of developed as a platform for this to drive their own stories of what interests them in climate change. So they'll do research about a current issue in climate change and use our template to create a story and an experience that other people can either play or view or VR, however they want to do it. This was quite the project to begin with, but putting it into a project-based learning methodology was also another challenge. So making the project was the challenge, but also making it a project that students can use to create their own projects was also another challenge. So one of the main things was to align it with standards. So on the resources, you can see I'm aligning it with the Iste Standards. I was actually a presenter at Iste this year, specifically about my game design education stuff. So if you look at the Iste Standards, it shows that these are the main standards that I'm hitting, so that they are empowered learners that leverage technology to take an active role in choosing and demonstrating their competency and learning goals informed by the learning sciences, digital citizens. So a lot of this talks about the rights and responsibilities of being a citizen digitally, and innovative designing, computational thinker, creative communicator, global collaborator. All of this ties in closely with the project we're working on. They would definitely have to hit all of these standards and substandards. These are all on the site, so you feel free to check those out. Also, it's closely tied in with two of the different next generation science standards. So the science and engineering practices in the Ngss standard is the first one. So just to make it brief, the 8 practices of science and engineering that the framework identifies as essential for all students to learn and describes in detail are asking questions for science and defining problems for engineering. So we're asking the question, why is the Earth getting warmer overall, and how can we fix that? Developing and using models, we're modeling it digitally with scientific data. Planning and carry out investigations, which is literally what we want each student to do. Analyzing and interpreting the data, so they'll use the data they'll analyze it, interpret it, and present it in a sort of visual format. Mathematics and computational thinking is basically built into all the game design programming languages and stuff we'll have to use anyways. Constructing explanations for science and designing solutions for engineering. That's the core of this project. Engaging in argument from evidence, obtaining, evaluating, and communicating information. So I think the project hits these really well. Another set of standards from the next gen science standards that I was looking at that really does incorporate well with this project is the Science, Technology, Society, and the Environment standard. So when I saw that one, I figured, okay, we're using exactly those things. And this project can be used, students, if they want to talk about societal problems as well. It doesn't have to necessarily be climate change. It can be, political climates or, societal things where regardless, you have a map of the whole world, and you can have geolocated data, and a student can say, hey, I want to talk about what's going on in Tibet or something, and then you can click. They can set it up where they click and it spins the world. You zoom in, and now you're in Tibet, and they can present a story there about what's going on. So we're using science and technology to bring the experience and educate students and the viewers about society and the environment. There's two core ideas. So the core ideas of this one would be that scientific inquiry, engineering, design, and technological development are interdependent, which in this case is entirely true. And the second core idea is that it focuses on the more traditional STS theme, that science and technological advances can have a profound effect on society and the environment, which I don't know if game design or simulation can do it, but we're sure going to try. Another set of standards that I use, this is for my high school level CTE game design courses, is the California CTE Arts Media Entertainment Standards. The course, if you do my courses, they are articulated with colleges, and they also follow all of these CTE standards. So by going through the course, you will hit standards D1 through, I believe, D10. And that's also linked up if you want to check that out. So project-based learning planning, I kind of really affected what I wanted to do with this project. So originally we didn't know what to do with it, but we figured it might be a good learning tool. So how can I turn what we developed into something that other people can use to develop their own stuff? So as far as project-based learning goes, quick explanation. I found the PBL work site to be the most informative and most straight to the point and most helpful. It's so PBL, or project-based learning, is a teaching method in which students learn by actively engaging in real-world and personally meaningful projects. So in my climate change project, I asked the students to pick something that personally is meaningful to them or has impacted them individually. And it's a lot of the project-based learning has to do with students kind of not having set instructions of step 1, step 2, step 3, but here's the problem, here's what we feel about it, and let's figure it out together how we're going to accomplish this. So it really delves into critical thinking, collaboration, creativity, communication skills. And if the students choose what they're passionate about, it really does, as the site says, unleash a contagious creative energy among students and teachers. So I found that just having students do a regular project, is not project-based learning. That's just a set of steps. That's a tutorial. Project-based learning is they have a project and they learn themselves with the help of the teacher and other students how to get to a conclusion. And through that learning is how they figure out all kinds of problems, or how they figure out all kinds of solutions and learn new skills that are highly in demand in the modern job marketplace. This site is really cool. I recommend checking it out. Here's some of the gold standards for PBL, aligning them to standards, building cultures, managing activities, scaffolding. It goes round and around. The sustained inquiry, the authenticity, the student voice, the reflection, the critique and revision. The public product I found interesting because that's really what we're going for here, is to at least produce something, if it's a video or a playable simulation or a game, and a challenging problem or question, and then you just go in circles here. Let's see. Yeah, so the most valuable thing I learned from this course and putting together all this project-based learning stuff is that a set of instructions is not necessarily the most helpful thing. It's having students identify the problem that they're passionate about and figure out how we can solve it using different tools and methodologies. Hopefully, the game or the simulation or the template, whatever you want to call it, is a good jumping off points for students to be able to do that. I do have it set as a 1 month, so it's a quick 4-week program, and it's every day. We have assignments set up of what to do, and it'll be a quick prototype, and it should be pretty passionate and cool. I'm planning on using this either next semester or next year. I want to do a little bit more development, but I think next year would be great. I'll give a quick little video here of what it's kind of about. So you start off, I forgot to mention entirely like the metahumans aspect of it. So each student can create their own virtual human as well. So we have a duplicate of ourselves and a duplicate of the world. So this is mine. I know it's not entirely like me, but you know, one can dream. So a student can make their own metahuman, thanks to Epic Games and Unreal Engine, and use that as their avatar to explore the world and explore the problems that might exist. And as you can tell, these are really high quality, cutting edge characters. This stuff can be done by any student in a browser and imported into Unreal relatively easily. I wanted to show a little bit. So what we do have set up is we have like a space station that we use as our base to research problems that are going on in the world. So in this, or in our original idea, we were a group of humans that had to leave the world that we destroyed, that then developed time travel. We came back to the point where it was teetering on the edge, which is now, and we wanted to identify like what we could have done differently. So we have the spaceship. Let me lower the volume a little bit. And then from there, each student can make, there's the world down there. We can make these teleporter rooms where you can, those were where the climate change experiences are. So from there, you can jump in, for example, a hailstorm in Denver based on recent change. So we use particle effects and different techniques to make it hail in Denver. And all of this is actually Denver photogrammetry and LiDAR data gathered from cars, airplanes, different sources, and it's all publicly available through ArcGIS and other sources. So that would be, you know, one scenario if you wanted to talk about why there's hail in the middle of summer, and it teaches how to do different things in Unreal, and it's, you know, it's a quick little experience. Here's another one going into the Great Pacific Garbage Patch, which, if you're keeping up with the news recently, they're trying to clean it all up right now. And this kind of teaches how to do buoyancy, how to do water techniques, lighting, and just puts the person in the middle of the garbage. So this could be another example. You can go back to the space station. We can go Australia wildfires. So this is Australia. Some of the data takes a second to pop in, but you can see it's all smoky. We did have a more in-depth one with actual, you know, forests on fire and stuff, but I think you get the data, or the idea. Last one I'll show is Droughts in California. So quick little demo of, hey, let's go check out Lake Oroville. This is based on real data of the lake levels dropping. So you could say over time, this is what it was, that's what it was. Same thing can be done for like glaciers or carbon levels or whatever kind of point you want it to make. And, you know, it impacts our drinking water here in California, which is a societal problem as well that we're trying to tackle here. This is just one part of it, so there's a whole nother aspect where you can go to that's our little drone ship. This is the mothership. You can fly the mothership all around the world wherever you want, as you can see. Bear in mind, this is still all beta or alpha or whatever. And all of the data that was used is from Leeds, University of Leeds, which is posted on the site, which is all this donut theory of economics. If you check the site, you'll understand more. I don't want to go too in-depth about it, but we kind of gamified the data of, I guess I'll show it real quick, on the resources page. So here's the data. you can see each country has kind of a score for like what their CO2 emissions are, their phosphorus, their nitrogen. So the ideal would be kind of in this middle zone. So we're not overextending how much we're hurting the environment, but we're also taking care of the social foundation too. So there's a social aspect to it. It's not just about the world. Like humans have to be thriving as well. So we want it somewhere around here. And this is all backed up by hard data from a study that you can check out here. But anyways, that is incorporated into the game. And you can go to each country and collect the data for each country, and it'll go on that board, and you can kind of score them. Students could find a way to manipulate that data by, say, if we install, 1,000,000 solar panels or wind turbines, maybe it'll change the data or something like that. So this is kind of just an open template for students, researchers, developers to tell the story that matters to them about the Earth with hard data and make a compelling simulation or at least a video about it. So hopefully that explained somewhat about what my goals are with this. And yeah, I found this whole class really informative. The whole process was great. And this is going to be something that I'm going to continue to work on for the next, foreseeable future. So thanks for watching, and I'll see you later. Stay tuned.